Hello, I'm Kevin Smet, advanced student at Learning Alias, and this is going to be a power video on the curvature evaluation shading options. So I have a wheel arch here, and I just want to show the curvature evaluation shader and the different options. Now, Prink Max is the default, and Prink Max is a good evaluation mode, but the problem is if the scale becomes too high, you get irreadable plots. Let me demonstrate. If I slide it down, it's pretty easy, right? We see a nice, clean, and consistent concave area. And then here we start seeing a pretty nice and consistent convex area. But if we keep pulling it up, look what happens. Let me zoom in on that. You can see that it starts to go all weird and it's completely illegible. Once the values are too high, you get a stair stepping effect, which makes the plot illegible. So I don't really like Prink Max for that reason. Shader that is most similar to Prink Max is the mean shading. It gives you a very similar characteristic, but it won't blow out on you like that. So what the mean shading does is it takes the two principal curvatures and it averages them. What's the principal curvature? Well, the curvature along U and the curvature along V at any point across the surface. Those two curvature values will get averaged, and that will be a color plot, in this case, mean curvature. So with mean curvature, we get the same kind of thing. If I slide it down, you can see very neat and consistent concave area to the blend, and then a very neat and consistent convex area to the flange. But if I scale it up, and I can type in a value to go even higher, you can see it never gives me that stair-steppy bleeding effect. You can see perhaps a very little area here, but that's just because of my tolerance. So I can slide it up and I can really evaluate how that curvature is coming along. To definitely know is the use of Gaussian Shader. Let me turn off the model. And with the Gaussian Shader, it's very easy to see gaps where one surface ends and the other starts. For example, here. If I turn the model on, you can see that we have surface boundaries here. So with mean shading, you don't really see that. However, with Gaussian shading, you see it very well. So you might say, oops, I need to work on it some more. However, Gaussian Shader actually shows you breaks in your surface set which are smaller than your tolerance. So really you shouldn't care about it too much, but you should know about it. So basically what do I mean by that? Well, it looks good with mean shade, I hope we all agree, and it looks bad with Gaussian shade. I hope we all agree on that as well. However, if I go to the regular multicolor, I turn on the model, and I put a surface continuity, checking for curvature continuity, across this boundary, you can see it's actually curvature continuous. In fact, all of its little neighbors are as well. So if I pick this locator, and I go to the information window, you can see the values I have for the continuity. These are the tolerances I'm shooting for. These are the tolerances I'm getting. And you can see that the angle between the normals is actually only a fraction within my continuity. So is this a problem or is this not a problem? Well, we have a tolerance in order to use it. So we are within tolerance, so everything's okay. However, 0.1 as an angle deviation, it's still maybe a little bit high. It all depends on the surfaces. It is an executive decision. The gap might be 0.01 instead of 0.1, but angle and curvature tolerances of 0.1 are relatively standard in industry. So this is something that you will run across, even by using, for example, CATIA V5 construction options. This has been a power video on the curvature evaluation shading methods, some of them at least. I have been Kevin Smet, advanced student at Learning Alias.